Good morning, everybody. So I welcome to this lecture series, my dear students, so that during this social distance period, we can communicate with you the due lectures what we couldn't complete during the regular classes. So I'm so happy to share such kind of important reduction formula in our syllabus, which is provided by Dhanamajuri University in Pal. So last time I have supplied some lecture notes, as well as we have done so many formulae during the regular class period. So this is a 12th reduction formula, and this reduction formula is very important. Why it is important? Because you have done about the reduction formula of ax squared plus bx plus c to the power n dx. So it seemed very difficult, but it was very easy. Why easy? Because you can make a perfect square of the inside the bracket, and then you can integrate as we did earlier. And then another one, 1 by ax squared plus bx plus c to the power n. So this kind of reduction formula also we have done very easily. And if you have any problem regarding these two formulae and other related formulae, then you can communicate with me through WhatsApp, or you can directly call me. So now let's come to the point. So this is to find the reduction formula of sin power mx and cos nx, cos power n. So it is very easy that to integrate the multiple of sine and a cosine. But here it becomes difficult. Why it is difficult? Because it has the integral powers, sine and cosine. So if you integrate it, and as you have earlier known about the integration by parts, and I pronounce once again that integration by parts of two functions in the form of multiple, say suppose u and v. The integration by parts is done that first function constant and the second function integration minus integration of the differentiation of the first function and the integration of the second. So likewise, here if you integrate from these two functions, then you will find very difficult. Why it is difficult? Then if you put this first function and this function second function, then it will be circulating again. Therefore it makes us difficult. Therefore we simplify it like this: sin to the power mx, and this cos to the power n is say reduced as cos to the power n minus 1x and cos x. So the multiple of this becomes cos of nx. So now we put this sin mx and cos x as one function together, and this cos power n minus 1 is the first function. So as we have known earlier, integration by parts, we do like this. This is taken as first function, and this is taken as second function. So now, according to the rules of the integration by parts, first function is constant, second function is integration, and a minus differentiation of the first function and integration of the second, as you know. And then it is very simple that the integration of this becomes sin power m plus 1 x divided by m plus 1. Then this is also the differentiation of cos. Cos is taken as one variable here. U to the power, you take u to the power n minus 1 as we did in the classroom. The power is coming as coefficient n minus 1, and then the variable power is decreased by 1. That means it becomes n minus 1. Then differentiate this cos, then this becomes minus sin x into, then this becomes sine of this m plus 1 divided by m plus 1. You may be complicating here the integration of this and this. This integration and this integration are same. So let's do here. say the integration, as you know, it is taken as first function and this is taken as second function. First function constant, as you know, then integration of the second, minus differentiation of the first function and then integration of the second. As you know, the integration of this cos is nothing but it becomes sine, minus the differentiation of sine is very easy because it becomes m and sine to the power m minus 1, and then the differentiation of sine means this becomes cos. Then the integration of this becomes sine x again, all dx. So this becomes sine to the power n plus 1 x, because the multiple of sine nx and the sine x becomes sine to the power n plus 1. Here it is m. And what is sine into sine? This becomes sine of mx into cos of x dx. This means this becomes the original integration. Say suppose if we take it as I, then this will become then naturally this becomes I again. Then by transposing m plus 1 into I, if you combine this and this, like this. Therefore, if you want to find I, then this becomes sine of power m plus 1 x divided by n plus 1. Therefore, it is this. From this, we have known that the integration of sine power mx cos x is nothing but sine to the power m plus 1x divided by m plus 1. Here also. So from here, this becomes cos of nx n minus 2, and this is sine of m plus 2. Sine of m plus 2 means it may be m plus 1 plus n minus 1 divided by m plus 1. It can be reduced as cos of sine of m into another sine square x dx, as you know. So now m plus 1 taken common. So this will be m plus 1 into m n j o. Plus here it is n minus 1 into then cos of or n minus 2 x. Sine square means it is nothing but by the identity, this will be cos square x, all dx. So this becomes cos, this and this becomes cos of dx minus n minus 1 into plus minus minus, then this will be integration of cos of power nx into sine power mx dx. That means this becomes the original integration, that is j of mn. Therefore, if you transpose m plus 1 plus n minus 1, j of this will become j of mn. Then this will be equal to sine of m plus 1 x cos of power n minus 1 x plus n minus 1. By the generality of the reduction formula, then this integration is nothing but j of m comma n minus 2, because we have to write about the sign first. Therefore, it is nothing but, if you want to find the reduction formula for this j of mn, then this will be equal to sine of m plus 1 x cos of n minus 1 x divided by m plus n. Here it is n minus 1 divided by m plus n. And then this is j of m comma n minus 2. So now you see the reduction formula for this sine power mx and cos power nx. So this becomes this integration, where m and n are integers. So for this we can take one example. One example means this is indefinite integration, and in the definite integration, if we want to find out the limit, then we can do like this. So suppose the integration is from, if the limit is given, sine power this. What shall we do then? This will be, that is j of mn. No. Integration of 0 to pi by 2 it is nothing but j of m comma n, taking the limit from 0 to pi by 2. Is it okay? After this, what we know, the reduction of this will be, it is very simple, that sine of m plus 1 cos of divided by m plus n, this one 0 to pi by 2, and then plus it is n minus 1 divided by m plus n, and then this is j of m comma n minus 2. So the limit is given here 0 to pi by 2. So this integration is equal to, this is already 0. Therefore, the general formula of this reduction formula for the integration of 0 to pi by 2 will be n minus 1 by m plus n, j of m comma n minus 2. So the limit you can take here only 0 to pi by 2. So that is, therefore, integration from 0 to pi by 2 is nothing but, this is n minus 1 divided by m plus n, and it is j of m comma n minus 2, the limit 0 to pi by 2. So this is the only limit. So when you get the exact values of these two integers, that is m and n, then you can easily find out the limit of this integration. Therefore, I assign you one question that find the reduction formula for, suppose, integration from sine to the power n, instead of n, this is specific value is given. So you can find out this integration.